Hello and a very good evening and also happy holidays, whatever you're celebrating or not celebrating. And this is our yearly traditional trip to the PowerBasic world. We're doing a Let's Code MS-DOS using PowerBasic 3.2. This is the German version, but the UI is still English. PowerBasic is a compiler for BASIC running on MS-DOS, producing executable files, so no interpreted nonsense like GWBasic or QBasic. We get real exe files, and this was the programming language I was using as a kid first, because there was a cheap version for around 69 German marks, I think. There was something that I could save up to and actually buy, and I programmed my first interesting little things on that. So once a year I circle back to this, and yeah, this year we are going to do something because we're already past Christmas and on our way to New Year's Eve, something in between. A 3D Starfield, I thought, would be a nice thing that's fitting both for Christmas as well as for the New Year, maybe. We did fireworks a couple of years ago. You might want to check that out, which was also, I think, a very nice effect. But this year, it's going to be all 3D stars. And we're going to write it from scratch, so I'm gonna type in my listing as I designed it. It has some striking similarities to the fireworks one, because I took that and ripped everything out that I didn't need. But there are some functions that I will be repeating and some structure. First of all, we start with the compiler directives. Those are special keywords like $CPU. We're gonna target the, if I can actually manage to do that, the 8286. At the very least, we are gonna use the EGA library because we're using EGA screen mode, so we need that. We will turn off all errors. I forgot what that's for, but yeah, I think it's probably not necessary. We are optimizing for speed, so that should be as fast as possible, and we're compiling an exe file. Those things are all optional, you can leave them out and it will still run. Also, we say that by default, all the variables starting with A through Z are integers if we're not doing anything. In BASIC, you have to specify the type by appending a certain character to a name of a variable. For example, this here would be a string, this here would be an integer, this here would be a double variable, double precision variable. And I don't want to write percent all the time, so I say these are all integer variables. We also need a couple of arrays, double precision arrays, one for the x coordinate of the star in question, one for the y coordinate, of course, and at maximum 256 stars, because otherwise it will get too slow. And of course a z variable, the depth into your screen, basically, because we're doing a 3D Starfield. You probably maybe know the Starfield screensaver from Windows 3.1, maybe not, but it's a very classic, cool, nice old effect. And we also need a delta t, basically, which is the speed of each star, because they will have varying speeds so that it looks more interesting. And we need a variable that defines basically constant, but BASIC doesn't have constants per se necessarily. So I'm calling it depth, and this will be initialized with 10. This is how far away from the camera will new stars be spawning, so to speak. And then how many stars are we using? We can start with 100. You can use up to 256, obviously. And we need two variables keeping track of the video page, because we're using double buffering so that we don't get any screen tearing or flickering. And it's not active and active, it's active and visible. Active is the screen page that is currently being drawn to, and visible is the one that is being shown. And this will be swapped around every other frame, so that we always write to the one page that is not visible, and we will display the one that is not being written to. Then we need some random numbers, so we call randomize timer. This will take the current time of day and feed it into the random number generator, so that every time you start the program, you will get a slightly different star field, and not always the same. Furthermore, we're running in graphics mode. And at some point at the very bottom, we'll go back to text mode. And you can look up the screen modes that are available in the help function, and this will be here. Again, the help here is in German, but you can download the English version of PowerBasic 3.2 as well. But you can already see that, where's my mouse cursor here, that 7 is actually EGA. Next up, we will sketch out the overall structure of the program. At first, after initializing the screen, we will initialize the palette, because we want to have the stars to be first very dark, and the closer they come, the brighter they should get. And in EGA mode, we have 16 different colors, but we will be using the VGA card only. So this will not run very nicely on the EGA card, because we will be using the fact that the VGA card has a lot of gradations of brightness, and we'll set the palette so that we can have 16 different shades of gray, basically, or white, and use those, depending on depth, to paint stars that are nearer to the camera brighter. So that's what we're doing with the init palette. Then we will call the init new particles function to initialize the star field. And this function will require the X array, the Y array, and the Z array. And it will fill this with numbers. Also, the speed will be initialized, and it needs to know how many stars it should create. So that's fine. And then we will be running a loop. Do loop until instat, and this means do this loop until the input buffer of the keyboard has a status that is not 0, basically. So a key was pressed. Do this loop until the key was pressed. This will stop our program. And every time in there, we will call update particles. And update particles will work the same as init new particles, but will, well, update them with the given delta t's. And if a screen zooms past the camera, we will replace it with a new star, a new random star at the maximum depth possible. And then we can also draw all the stars. We call this draw particles. And this is actually named the same as in the fireworks simulation. We don't need the DT for that, because for drawing we don't need the speed. And after we have drawn everything, we will swap the active with the visible buffer, and that means we swapping the variables, and then we will actually set the screen pages. You can do that by leaving out the regular screen command, so we don't switch graphics mode, but only the active and visible screen function. Then we wait for the vertical sync pulse to arrive. We will have to code that. We did that in the fireworks, so I'll just repeat that. And then we clear the currently active graphics buffer, so we have a clean slate and the stars don't create any trails, so to speak. So I think the first thing that we are getting out of the way is the vsync function. I'll put that up here. So it will be called vsync, and it will be an inline function so that it will be inserted and we don't have any overhead. And last time we did that in assembly language, so we'll do that again. First we disable all the interrupts so that we don't get interrupted, because otherwise we might miss a blank signal, so to speak. This will limit the frame rate to 60 or 70 Hertz depending on which graphics card you're using, but it should usually be 70 Hertz, so 70 frames maximum, so that it doesn't get too fast. Then we have to load the DX register with the port on the VGA card that has the status bit for the retrace, that is 3DA hexadecimal. Then we define a new label called vsync1, and we will read from said port, and we will compare this by handing the red value with 8. This is bit 3. Bit 3 has the vsync information, and if this is not 0, we will jump to vsync1 again and wait until this turns 0. Then we have a second one where we wait for the vertical sync to... This is basically, if we're already in a vertical sync, we wait until it has finished. Otherwise we might miss it, the start of the next one. Then vsync 0 means we're not in a vertical sync. So we're doing the same again. We are reading into AL the value of this register. We are again ANDing this with the third bit, or 8 in decimal. And then if we are 0, we jump to vsync 0. So that means we are waiting, or we're looping the whole time that the vertical blank is on. And then we are again enabling all the interrupts. So that should not compile because we're missing some functions. But that's that. That should be fine. Then we can initialize the palette. Init palette and sub. Here we are going to do a for loop. We don't need to change the color black. That's fine, so we leave it out. So we're doing the run variable I from 1 to 15. And we loop with next I. And there we are writing to the VGA palette index register. We're going to write a hexadecimal 3C8, and we'll write out the index we're writing to. This is strictly only necessary once, so we could write only a 1 there, but I'm going to do it the long way. And then to the data port we write the actual value, and we need to do it 3 times for R, G, and B, and for grayscale that's always the same. And I thought it'd be most nice if we get the value 63 for color 15, because that's the brightest value we can get. That would be a bright white, because there are 64 shades in every color component. And we get that by incrementing I by 1, so it goes from 2 to 16. If we take 16 times 4, that is 64. That's 1 too much, so we subtract 1. And that's basically it. That's what you get out of that. This will give us a color ramp from black, because black is already black, to white. But the problem is you can't do that on a VGA card. That won't work. But there's a nice feature, because the 16 color modes don't have the colors mapped from 0 to 16, but some weird way. But in PowerBasic you can actually do the VGA programming by using the palette command, and we just tell it to map the value that we just took to that actual color value. So I, I will map attribute I to color number I. And that actually works. Don't ask me why, but I think PowerBasic does some weird setup in the beginning. Okay, that's cool. What else do we have missing? Init new particles. Yes, that is a good one, I think. That's what we should implement next. So sub init new particles. However, for that we will need also something different. But let's do that first, and then we'll see what we require in also other functions. We're going to take a one-dimensional array. This is the syntax for telling it it's not the first element of an array, but it is in a one-dimensional array. We take all the arrays, x, y, z, dt. We could have also made this shared variables, but it's not good structure to basically just make everything global. But we would have gotten away with this, I think. So we're going to iterate over all the particles, just as usual. And then we will call a function called new particle that takes exactly the current element that we're working on and will initialize it with nice values. And this is actually where I said there's something that we still need. And that is this function here. So we'll implement it straight away. And we will call it something like so. I think that's nice. New particle with x, y, z, and dt passed to it. And x will be going from -50 to +50. So we take -50 plus 100 times R&D. R&D will return something between 0 and 1, so the value it will return will be between 0 and 100. So the final thing will be between -50 and +50. You can play around with these values and it will give you different shapes, so to speak, but this should be quite nice. For the y value we take the same thing, and for the z value we'll do something, some random depth, I think, times R&D, something like that. And dt will be something like 0.01 plus 0.1 times R&D. That should be nice, I think. Yeah, for the new particles that we will create later, we will have to adjust this part here because we want it always to start at the maximum distance. But for now, this is fine. We can live with this. Or maybe we can move this here. Yeah, let's do that. Let's change my source code that I have prepared. It's always a good idea. So we'll ignore, actually no, we are not ignoring that. We just set this to the maximum depth. And here we will just override this with our own function, so to speak, in the new particles. For completely new Starfield, we will set a random depth so that we're already starting with a Starfield that has moved a bit with a random depth. And for new particles that are appearing, they always start at the maximum depth. I think that's a good change. Okay, now we have particles. Now we need to update the particles and draw them. Those are the next two functions. So let's take this bit here, update particles. Here again, we take one-dimensional arrays, which is fine. and we'll update it. Again, we will iterate over 0 to n-1, next I, and then I wrote a comment here, move stars and create new ones. Yeah, makes sense. So first we update the z component, because that's actually the movement, right? The movement is only the z component. And this will be the old coordinate minus the speed that the stars are moving in, because we're moving from positive infinity to minus infinity. The camera sits roughly at the origin, so at 0. So if you want to move the stars closer to us, we have to subtract our current velocity from the z component. And now if this z component is smaller or equal to 0, then we need to do something. We need to create a new star, and we already know how to do that. We call new particle with our known stuff, I would say, with exactly this stuff as the option. So we can reuse the new particle function, which is nice, I think. That should be fine. Now we update the particles. If the particle zooms past the camera, we create a new one. Or at the maximum depth. We're not changing the depth to a random value. That's actually pretty nice. Now we do the drawing. Let's see, draw particles looks something like this. So we'll copy that. Sub, draw particles, one-dimensional arrays that we're passing. That's fine. And we're doing another round of iteration. I from 0 to n-1, next I. And now we have to calculate the projected screen coordinates. So that's integer variables. We take 160 plus 10 times our current x coordinate. The 10 times here is basically the focal distance or the zoom factor. If you take a lower number, everything will be very wide angle. And if you take a higher number, it will be like looking through a telescope, so to speak. Divided by the z component. And as we filter out particles that are at 0, we shouldn't normally get a division by 0. But you have to, in theory, you have to take care of that. The 160, by the way, is the middle of the screen in the x direction, and in the y direction this will be 100, so that our star field is centered around the origin, around this point on the screen, so to speak. And for y, we of course use the y coordinate and scale that by the z component, obviously. That's something I mistyped. For perspective projection, you always divide by the z component. Yeah, we need a color. This is our new color. The color will be the z component that we have divided by the maximum depth that we're using. So this way we get a number from 0 to 1, depending on how deep the star is, so to speak. And we want to scale that to a color number, so we take this 15 times z, so this will be a color from 0 to 15. However, this will mean that we get a 15 when the star is very far away, when it's at maximum depth. But we want the other way around, so we can invert that by writing 15 minus 15 times, so and so. Okay, this is nice. And we don't want the stars to flicker. If there's a star that is nearer or closer to the camera, we don't want to overwrite it. So we also take something called old color, which is just the point at position px, py. This gives us the current color, basically. If it's black or very dark, we might want to overwrite it if we now have a brighter color. So If old color is less than new color, then we actually do overwrite this. And setting a pixel is can be done by pset. It takes px and py, plus it takes a color, which is new color. And that's it. That should be it. Let's see if it compiles. No errors. Let's see if it runs. It does, but it doesn't do anything. So, debugging time. All right, found the bugs, and I hope some of you have been screaming at the screens. The depth variable here was missing the hash, which means it's a completely different variable, and everything was 0. And there was another bug that I remember, hopefully. I think there was, instead of a dt, I wrote a dy, and that made all weird stuff, because we don't have a variable di. But yeah, now everything should be fine. We can compile it, and it does compile, and we can run it. And there is the Starfield. And as you can see, new stars keep appearing in the background, but they are very dim, and the closer they can get, like this one here, the brighter it will turn. Like here's another one that gets brighter and brighter. And once they reach the camera position, there will be another star being spawned. And you can play around with the number of stars, of course. Let's crank this up to the maximum, 256. And you see it already gets a little bit slower, because we are emulating a, I don't know, slow 486 or something with 10,000 cycles here. And it's already has to churn quite a lot, computing all those stars. But it looks quite nice and dense, doesn't it? It will get faster if we turn it down to, let's say, 50. But there will be the limit of 70 frames per second or something like that. And yeah, you can play around with that. It should be fairly easy to do that. Yeah, I think this looks very nice, 150 stars. And we are only running in 16 color mode, because for the grayscale, that's totally fine. We don't need VGA 256 colors or anything. Let's quickly recap. We have a couple of functions, the init palette, which does the grayscale and does the palette command to remap the colors to the attributes. We have the new particle function, which sets a new star at a certain depth, but with random x and y coordinates and a random speed. We have the new particles, which will create a whole new star field with random depth added. And I think there was also a typo here. I think that was just z hash or something. So that would have worked either. And we have the update particles, where we move along the z-axis according to the speed. And if we hit the camera plane, we will create a whole new particle instead. Then we have the draw particles, where we do a perspective projection according to the screen coordinates. We are choosing the middle of the screen as our projection center. And then we're doing a zoom factor of 10, and you can play around with that again. If we put this to 1, for example, it's very zoomed out, it's very wide angle, and you have this clustered star field at the center. And once the stars get closer to the camera, they get very, very fast, obviously. And you can also do it much more zoomed in, like 20, but that is like too much zoomed in, I think. I think the 10, but I mean, it depends on what you like. I think the 10 is a very nice in-between zoom factor, and that looks actually pretty neat. But yeah, feel free to play around with these variables. Then we do have some kind of z-buffer by comparing the color of the old and the new pixel, and we are only overwriting if our pixel is brighter. Otherwise you get kind of flicker. For example, I can turn this off, and we might see some flickering sometimes, but collisions between the stars at this depth of or density of stars is actually pretty rare. But if we, for example, crank up the number of stars more or less all the way to the maximum, it might actually happen that there was this star just recently overrode a brighter star, and this can be annoying if you do see that. So yeah, it is not strictly necessary, but it will make it even more perfect, let's say, if you enable the Z buffering, so to speak. Yeah, and that's more or less everything there is to this thing. Maybe the vsync should happen somewhere else, but I think this is fine because we're double buffering, it doesn't matter. Yeah, I do like this Starfield simulation. I think I coded this a couple of times over the last decades in different programming languages, but it's always nice to see. And yeah, with this, I thank you very much for the past year and hope to see you in 2026. And I hope you have a very nice and relaxing time. You're healthy, and leave a comment with your favorite basic or PowerBasic story, MS-DOS coding, adventure, or whatever's on your mind. So see you in the new year and have a very, very excellent evening.